And so if we look a bit back at Silverlight 1.0, it gave you a really easy way to connect to outside media directly through the XAML. So basically, all you had to do is specify a URL to an external resource, and everything was handled for you automatically. The problem was that there wasn't really an easy way to communicate with all of these other different types of services. And so what you had to do is you had to remember that a Silverlight control is actually on an HTML page, which can have JavaScript code on it. And that JavaScript code can use your regular standard AJAX techniques, like the XML HTTP request object, or even an AJAX framework like ASP.NET AJAX. And using those AJAX techniques, it could talk to these services, or at least to some of these services. And then also the same JavaScript code could then interact with your Silverlight control. And so you had this indirect and often very inefficient and hard to use channel to these different service types. And so all of this is getting much better in Silverlight 2. You can now write managed code to directly communicate with all these services. And so two questions naturally arise here. One is, what does this client-side code actually look like? What do you have to write to receive and send data? And the second question is, if your application happens to need a new custom service, what is the recommended way to create those services? And so we'll start by actually talking about the second question. And I'll walk you through a demo of actually creating that product catalog scenario, where we have a Silverlight application that's a product catalog, and we have a product database, and we'll build a service that serves up that data. And so I'll switch over to my demo machine here. So this is what we're trying to create. I have a Silverlight application. It's a product catalog. I can search for something. I don't know, I want to search for wine. I'm hitting OK, and nothing happens yet. I don't have it hooked up to any external data source. Let's look at the code. So I'm actually working with two projects here. The first one is my Silverlight project. This is where my XAML page is that actually defines what my application looks like. But this is my server-side project. And I'll start on the server side, and I'll start by actually creating that service that will serve up the product data. And the way I do that is by going to add new item, and I'll select the appropriate template. And so the recommended technology for creating services for Silverlight is WCF, or the Windows Communication Foundation. You'll notice that we already have templates here for things like an AJAX-enabled WCF service. We will also have a template for a Silverlight-enabled WCF service. It's still not present in the beta, so just select the generic WCF service template, and we'll have to tweak it a bit. But again, this will all get much simpler later on. So I'm going to call it shopping service.svc. I'm going to add it. So notice that if you're familiar with WCF, you'll notice that this is just regular WCF code. I have a service. It's called shopping service. I have one operation that's called do work, but it actually doesn't do anything useful yet. So instead of do work, let's call it get products. And it's going to take a string. That's my search string. And instead of returning void, it will actually return a list of products. And so let me actually create my product class as well. And the product is going to have a description. And it's going to have an image URL. So again, if you're familiar with WCF, you'll know that your services are supposed to have the service contract attribute, your operations are operation contracts, and your data types are actually data contracts. And anything you want to actually appear on the wire are data members. So now I basically have the definition of my contract, of basically what the service actually will do. There's one more thing I'll do. I'll go to my pre-made demo code. I'll add a constructor to my product class because I'll need it later on. Now that I have my shopping service defined, I actually need to implement it. I will go to my shopping service class and notice that it implements this iShopping service interface that I defined before. I would just copy a pre-made implementation that I already have. Normally what you would do here is you would actually go to your product database and look for products based on the search string. But for now, we'll just put a very simplistic implementation in there, which is, if it's wine, it's going to return a bunch of wine information. If not, it's going to return a bunch of cheese information. So great. I'm going to try building this. This works. So remember that this was a generic WCF service template. This wasn't Silverlight specific. I do need to make one tweak now to make it actually work with Silverlight. I need to change one thing in the configuration to make it use basically the simplest possible protocol, which is the basic HTTP binding. And again, this may seem complicated now, but it will go away once we have the real Silverlight template. And so now that I've made this change, let me just view this service in the browser to make sure it runs. So great. So I now have my service. It's fully working. Now I need to actually use the service from my Silverlight application. And so let me close down my server-side application and go to my Silverlight application. Let's go to the XAML. So you'll notice that this is very simple. I have a text box. It's called search box. It's right here. And I have an OK button that's handled with an OK click handler. And so I'll go to my code behind. And what I really want to do in my OK handler is basically do something like get products of search box.text. But of course, I can't really do that. My Silverlight application doesn't know anything about get products yet. So the first step I need to do is I need to add a reference to that service to my Silverlight application. So I'll go to my application and I will choose add service reference. And here I can type a URL to a service that I want to add. But since it's internal to my solution, I'll just hit the discover button and it will discover the shopping service in my solution. I will add that. I'll call it shopping service. And notice that it appeared under the service references. I can now have access to a new namespace called product catalog demo.shopping service. And so now I'm ready to use the service. Now to use it, I use it through what's called a proxy. And this is basically the object that think of it as holding a connection to the service. And so what I really want to do is proxy.getProducts. And so first I need to create this thing. And so to create it, it's really simple. I will just create a new shopping service client. Now when I go and try and use it, you'll notice that it doesn't have get products. It has get products async and get products completed. So we do not support the synchronous way of programming networking calls in Silverlight. Because if we were to do it synchronously, basically the UI thread and the user's browser would hang while the service is trying to respond. And so instead what we do is we issue the call asynchronously, and then the application will get called back on an event handler when the call completes. And so we call getProducts async with searchbox.text. And notice that this thing returns void. So the way I actually get the results, again, is I need to set up an event handler. So I will set it up. I do a proxy.productsCompleted. And I add a handler to it using +=. And Visual Studio makes it really easy for me. I just hit the tab key twice. and it builds me a stub for my event handler. So this is the method that will get called when the service returns. Notice that I have basically full IntelliSense over the results, so I can go into e.results, and it's of type product array. I can go into the first result, and I have access to the description. I have access to the image URL. But this is not really what I want to do. I want to show you how to directly bind this to the UI. Because all of the code that gets generated when you generate a proxy, when you add a service reference, it fully supports data binding. And so if you look at my XAML again, let me make this larger. You notice that underneath it, I have an items control. And items control is just a control that basically repeats the same XAML over and over again, and it can be easily bound to a collection of objects. And inside of my items control, I basically have an image whose source is bound to that image URL member. And I have a text block that's bound to the description. And remember that that basically matches my data members inside of my product data contract. And so I have this binding set up. So all I need to do in my results handler, and one more thing, that items control, I gave it a name. It's called results list. So all I need to do in my code is say results list dot items source is e.result, which is my array of products. So this is really it. Let me try and run it. I'll refresh it just in case. So I'm searching for wine, and displays products. And the other thing works too. So this is your full end-to-end, building a service, consuming it from Silverlight story. So to recap what we did, on the server side, we created the service. We then defined what it does, both in terms of the contract and the actual implementation of the contract. And then we came to the client side, we added the reference to the service, and then we could actually use it by creating a proxy and then calling methods on the proxy. So we'll go through these steps again in a bit more depth. Other things that we'll cover is how to migrate code that uses services from Silverlight 1.1 alpha, in case any of you were using that code base. Another thing we'll cover is how to actually secure these services that you create. So let's start with creating a service. As I mentioned before, the easiest way to create a service is to go to your website project or your web application project and choose Silverlight Enable WCF service. The template will do everything for you. It's not there in the beta, so for now you select Add New WCF Service, and you do need to make that one little tweak to the configuration to make it Silverlight compatible. Once the service is there, yes, there's a question? Sorry, I can't hear the question. Can you? Right, so the question was about WS Star support. There's actually no direct WS Star support in the beta. We do have basically the full WCF channel stack, and it's possible to perhaps extend it to cover some of the WS Star protocols. But there's nothing out of the box in the beta that does any of the WS Star. I really can't say anything about WS Star plans. But we'll talk more about kind of the interop case later, and I'll go through exactly what we support. This is more kind of the straightforward creation thing, and then we'll go into the interop cases. And so going back to how you build your service, You attribute, you basically write regular WCF code. There's nothing Silverlight specific there. Once you've created your contract, you've created your implementation, you go to your client side, you do add service reference, and again, you could reference an external service. We'll talk more about it later. We will also ship after the beta a command line tool that does the same thing. So you can integrate this into your build processes and so on. Once you've added the reference, you create the proxy. The simplest way to create a proxy will basically choose the default address for you. This is the address that was there in the metadata. You can actually use a different constructor overload and pass in your own address to connect to the service in a different place. Because the central question basically is what happens if the service moves after you've already created your application. And to really solve it, we're only really solving it after the beta, and we're adding configuration support. So actually, if I switch back to the demo for a second, notice that I have this file that was created for me here called servicereferences.clientconfig. And this basically holds the address of my service. Now, right now, that file is not really active, but after the beta, it will be. What it will do is you'll be able to go into that file and change the address of the service without recompiling your code. And that makes it easy, among other things, to create reusable Silverlight controls that can point at many different data sources. And so you can imagine creating basically something like an autocomplete text box. And in one instance, it will point at a service that serves up a list of cities. In another instance, it will point at a service that serves up a list of countries. And basically, it will autocomplete whatever the underlying service does. So once you've created the proxy, you're ready to actually make the call. As I mentioned, we only support the asynchronous programming model. So you need to set up the do something completed event. And it's trivial in Visual Studio with the tab support. And then you call the do something async method to actually invoke it. And so that just repeats the code that you already saw. Call and handling the results. Now when the results come back, as you saw in the demo, the results fully support being bindable to UI. And specific collections can be bound to item controls, list boxes, data grids, etc. We're actually considering a future possibility where we'll have more advanced data binding support, where you'll be able to basically invoke a service from XAML only without actually having to write code. So imagine something like a get products data source that you could just instantiate in the XAML. But that's still in prototype stage. So we went through the whole kind of end-to-end experience. As I mentioned, there's a couple of more topics to cover in service creation before we go to the consumption and the interop cases. So one interesting thing to cover is how do you migrate from Silverlight 1.1 alpha code that uses services. It is a breaking change on the client side. You'll need to basically remove all of your existing web references and probably remove some of the code that uses them. And you need to re-add these services again as service references. And the data format used to be JSON in Silverlight 1.1 alpha. It is now actually SOAP. But despite that, you normally don't need to change any code on the server side. And it seems kind of counterintuitive because the format changed. But actually, the most common server-side technology for 1.1 alpha was as a MAX JSON, and it actually supports SOAP by default as well. And so most of the time, your server side will not have to change. There's many more details in the documentation. I don't want to spend too much time on migration. The other topic I wanted to cover with respect to creating services is once you create a service, how do you actually secure it? And so what happens here is that Silverlight will basically reuse the same authenticated connection or the same authentication information that's cached by the browser associated with a particular domain. And so what happens is if you're logging in from your regular web page code, so for example, you have an ASP.NET login control, you're sending over some credentials, and your ASP.NET server will send back some authentication information, perhaps a cookie. If later your Silverlight code actually tries to make calls to that same domain, it will actually reuse that authenticated connection. And so your Silverlight code does not have to deal with user credentials, usernames and passwords. And that gives you a nice experience where basically a user needs to log in once to both the web page and any Silverlight contents that are on it. On the server side, once you receive that call, to discover the current user identity, you can use HTTP context.current.user inside of your WCF code. For this to work, WCF needs to function in a special mode called the ASP.NET compatibility mode. Once we ship the Silverlight template, the template will actually enable that mode automatically for you. For now, for the beta, you actually need to look at WCF documentation and figure out how to turn this on. This is actually 2 lines of code to turn on that mode. And so we talked about securing services. We talked about creating them. So we basically covered that whole basic scenario end to end, which is Silverlight app and a new service that you create. But there's all of these other service types out there. And the question still remains, what does the client-side code look like to consume all of these other different types of services? And so there are several approaches here. And the first one you kind of already saw, which is consuming a service using @service reference. And that's kind of fully automatic consumption, which is metadata-driven, meaning that we know a lot about the service and we can give you, for example, the full IntelliSense experience. You don't have to do any manual work. And this, of course, is only possible for services that actually describe themselves in some sort of a machine-readable way. And obviously, this is true of services that you create using the recommended way, as I've shown you. This is true of SOAP services that you may have in the enterprise, regardless of the underlying technology. It could be WCF, it could be Java, it could be SMX. This is also true of publicly exposed SOAP services on the internet. And finally, this is also true of SQL Server data services that most of you probably know as Astoria services. This is basically a technology that lets you easily create services on top of databases. And so all of these different service types expose some sort of computer-readable metadata. And actually, in all of the cases except for Astoria, that metadata is WSDL. And because we have computer-readable metadata, we can generate this proxy for you. And so we can give you this one-line service consumption experience with full IntelliSense. And to demonstrate the interoperable case, it's very similar to the product catalog demo. I'll show you how to access the live search API using Silverlight. I won't go through actually writing the code. I'll just show you the pre-written code. Basically, I went to the live search documentation, and it lists the metadata address for the service. And so all I needed to do is to go to my project, add a service reference, and in that dialog, give it this URL. And what that did is added live search to my service references. And now I can start using it. So I can create the proxy just like I did before. I can set up my search completed event just like I did before. That will get called when my results come back. And then I actually have to invoke the request. And so live search is actually quite a complicated service. It has a lot of different options. You can search for a specific language. You can have safe search options. You can search different sources of data, not just the web, but other collections. And so it would be really hard to try and consume that manually by constructing URLs and so on. But luckily, again, because of the metadata, we can give you full IntelliSense, and so you can discover all of the different options which are in the service. So, for example, I have location, I have my requests, and my requests I have these different types of fields. So it's really easy to then just go by the IntelliSense and construct a proper request and call the service. Now, another thing that I want to show in this demo is when the results come back, again, I have full IntelliSense over my results. So my results basically have this is basically just a search service, right? So it has a description, it has a URL. I just want to display the description in this case. So I'm using link over the results collection to just pick out just the description. So I'm going into the results and selecting the description, and I'm binding it to a list box control in this case. So if you look at the XAML, this is really simple here. I have a list box called live search results, and this is it. And I'm binding the item source of that list box to the results of this query. So let's see if this works. I'll search for the same thing. And here we go. The results are displayed. So going back to the slides here, the natural question is, and we kind of already talked a bit about this, what does this add service reference experience actually work with? And so the answer is that it works with any SOAP service that is simple enough, at least for the beta, and with the definition of simple enough is basically SOAP 1.1 that is compliant to the basic profile. There's a standard out there called Basic Profile 1.0 that defines basically the simplest type of SOAP service you can have, and we can consume these types of services. And the server side, again, could be anything. It could be Java, it could be WCF, it could be any other technology. There are a few restrictions. For example, SOAP faults are not supported, and we'll talk more about why that is. There's also some restrictions, mostly kind of corner case restrictions that are only there for the beta that will likely go away in the future. So for example, some corner case schema is not actually supported. And in the future, we're considering adding support for Astoria services or SQL Server data services through that same experience. So you would also be able to consume those through that same add service reference dialog box. Unfortunately, you can't talk to just any service, and that is true Silverlight-wide. There are cross-domain restrictions to consider, and I want to go into kind of an aside on cross-domain issues and talk about those for a bit. There is an issue with an application in one domain accessing content in another domain. And first I'll explain what the issue is and then how we actually address it. The issue is, consider a scenario where I'm logged on to mybank.com, I send over some credentials, I get back some authenticated information. Basically, I set up an authenticated connection to that domain. And then later, or another window or another tab, I'm running a Silverlight application from another domain, like evilapps.com. And that application happens to be malicious and unknown to me. And that application, in the background, tries to make calls to mybank.com. And so what will happen is, if we didn't have any protection in place, it would just reuse the authenticated connection I have to mybank.com. And then that malicious application could steal my data, it could change my data. And so to mitigate that, Silverlight is secure by default, and by default it does not allow those types of cross-domain connections to happen. And so normally, if you have an application on mysite.com, it cannot invoke a service on some other site.com. And normally, you will have a security exception thrown if you try that type of access. But then the question is, how did I just connect to live search? Obviously, this is not the live search domain right here. So the answer is that services can actually opt in to being callable in a cross-domain way. And so we'll go through a couple of things. First of all, how do services opt in? And secondly, if you're creating a service, when should you actually opt in to being callable in a cross-domain way? The answer to the first question is that services opt in by publishing what's called the cross-domain policy file at the root of the domain. And so the way this works is if we contrast two scenarios, and for example, that first scenario with the evil apps in my bank, where the call is supposed to be blocked. And the second scenario here is an innocent scenario where I'm just trying to mash up with a third-party data source. So like you said in my demo, it's live search, or here it's weather.com, where the service actually wants to opt in. And so on my very first call to anything on mybank.com, Silverlight will check for the presence of a file called mybank.com/client-access-policy.xml. And it will find that that file does not exist. And so it will block the call and throw a security exception. But in the case where the service does want to opt in, Silverlight will check for the presence of that file. The service would publish that file, so Silverlight will discover it, and it will let the call go through if the policy actually allows it. It's actually a bit more complicated than that. We actually support two different policy files, and we'll look for them both. We first look for the Silverlight policy file called client-access-policy.xml. If we don't find it, we also look for the Flash policy file called crossdomain.xml. And the reason we do that is because that file is already supported by a bunch of services which are very popular mashup targets out there. And so out of the box, we will basically work with all public services that already work with Flash. Yep. This has nothing to do with code access security. That's correct. So to just demonstrate this, I'll show you on the demo machine a couple of services which already have a cross-domain policy file published. So this is the live search service that I was invoking before. And the reason that worked is because soap.search.msn.com/crossdomain.xml actually publishes a policy file that allows access from any domain, which is why I could call it right here from basically from my localhost domain. Another example is catalog.video.msn.com. It's the MSN video service. They actually published the Silverlight policy file, client-access-policy.xml. You can see the format of the file. It's a bit richer than the Flash one. You can specify the domains that you're allowed to call from. You can also specify the specific URL space that's accessible in a cross-domain way. And so back to the slides. You understand now how a service opts in, but then the question is, for the services that you create, should you publish a cross-domain policy file? And that really depends on your scenario. And the two big scenarios, there are other kind of more corner case scenarios, but the two big ones are private services that are intended for your own application, and public services or mashup APIs that you expose to the world. So if you're creating something like the Flickr API or the Facebook API. And so for the private services, you do want to use browser-based authentication mechanisms to get that one logon experience where the user logs onto the web page and also gets access to the Silverlight content. You do not want to enable the cross-domain access. The reverse is true for public services. You actually don't want to use any authentication mechanism that's based on the browser because, as you saw before, it can be abused in a cross-domain scenario. But you do want to publish those cross-domain policy files. Now the question is, what do you use for authentication in the case of public services? And the answer is anything that's cross-domain safe, meaning anything that depends on the actual message contents or on the URL of the service. So for example, URL signatures, something like the OAuth standard, would work perfectly for public services. The other interesting and important point here is that you should separate these two things out into separate domains so that you inadvertently don't give cross-domain access to something you didn't intend to. And so For example, Flickr does this. It has an api.flickr.com domain, which actually publishes a cross-domain policy file. It has www.flickr.com, which is a regular web page. It uses cookies and all these things which are not safe for cross-domain. And that domain does not publish a cross-domain policy file. And that's common best practice. So we talked about fully automatic service consumption. We did this basically aside into cross-domain issues, which, by the way, are Silverlight-wide and don't just apply to add service references, it applies to any services. So what happens for services that don't publish computer-readable metadata? In that case, you need to do a bunch of work manually. And in that world, there isn't, if you think about it, there isn't really that much of a difference between a call to a service and just a regular HTTP request. And that basically arises when services just publish human-readable documentation. So for example, you go to create a mashup with YouTube, and you'll see that they publish documentation that the URL is supposed to look this certain way, and the responses will look this other way. And so there's a lot of these types of services out there. They go by different names: mashup APIs, REST services, POX or plain old XML services. Sometimes they use the JSON data format. But they all have in common the fact that to go from the human-readable documentation to code, you actually need to do some manual work. And the manual work is building the URL, issuing the request, and then working with the data. And so to demonstrate that, I'll show you working with Flickr from Silverlight, which is a typical REST type service. So if you look at the Flickr documentation, it basically tells you that this is what the URL is supposed to look like. And the particular type of request that I'm interested in is the photo search. And it has these following arguments. And it also gives me an example of a response. The response that will come back will be in XML and it will look like this. So I want to consume this from Silverlight. Of course, the very first thing I'll do is I'll check whether that's possible based on my cross-domain restrictions. So notice that the URL here is at api.flickr.com. I'll go to api.flickr.com/crossdomain.xml. And yes, it is allowed to access this thing from any domain. So I can proceed. I'll show you the code. The first thing I did here is basically create the URL with all of the correct parameters. And then I'm going to be searching by the photo tag. And so when the button to search Flickr is clicked, I'm going to issue a request to that URL plus whatever is in my search box. Now notice that I'm issuing the request through a class called web client. It's very similar to the web client you have in the full.NET framework. It's in fact just a subset of it that basically works with just HTTP. And it also, in Silverlight, only supports the asynchronous programming model. And so, again, I set up the download string completed event that will get invoked when Flickr responds. And then I call download string async using my built-up URL. And what I'm going to get back is a bunch of XML in string form. And so I'm here in my completed event. Now the question is, how do I work with that XML? There are several options, and we'll go through them. The easiest kind of ad hoc option is to use link to XML or Xlink. That's available to you in Silverlight. I'm actually doing something a bit fancier here. I actually am using the XML serializer. To use the serializer, I need to pre-build my types. So here I have, for example, my photo type, and I pre-built it in such a way as to correspond to what the response actually looks like. So notice I have all of these attributes here called ID, secret, etc. And so I pre-built this type and a bunch of other types that again correspond to the XML. And once I've pre-built the types, it's really trivial to consume the XML. I just create the XML serializer and I call deserialize, and then I have again my full dot programming model over the results. And again, what I'm doing here is I'm just doing a data binding, and I'm just binding another items control to my results. And so let's see how this actually works. I'm going to search Flickr for the same thing. And have my Flickr results. So if you're familiar with just issuing HTTP requests on the regular .NET framework, you recognize that that same code will work just as is on the regular framework. There's nothing really new here. It's more a subset than anything new. And this is, of course, good news for existing .NET developers. There are, though, some things which are specific to Silverlight, and we'll cover them. First of all, in terms of building the URL, we'll talk about what kinds of things can you actually connect to, what are the allowed protocols, and then what are the allowed locations. In terms of making the request, there's some specific things about how you make the request and what kinds of requests you can make. And then we'll talk about working with XML data and working with JSON data. And so in terms of where can you connect to, the protocols that you have access to are HTTP and HTTPS. There are some restrictions on HTTPS access and cross-scheme access. A few of them will go away after the beta. For example, there's no cross-domain access to HTTPS resources right now. We'll add that back. But some of those restrictions are there for security reasons, and they're there to stay. Of course, any requests that you issue in this way are also subject to the same cross-domain rules. And so if it's not a local URL, the remote server needs to have a cross-domain policy file. Where in the regular desktop framework, you could use FTP URLs or local file URLs. Those are not supported in those places. You can't give those types of URLs to a web client control. For non-HTTP services, as you heard in the keynote, there is socket support in the beta. It's kind of limited for now. It's only same domain sockets. It is useful for consuming those non-HTTP based services, but this is really not what the focus of this talk is, so I won't spend much more time on it. Just know that this is available if you need it. Yes?
Is WSE2.3 support out of box?
Is what, sorry?
Web service extensions, WSE?
The web service extensions are not. I'm assuming you mean the extra. Yes. No. So only basic profile soap services are supported. Yep. Sorry, what was the question? I believe for the beta, the restriction is that you cannot consume cross-domain services which are HTTPS, but that restriction should go away later on. We'll talk about verbs in a couple of slides. In fact, when we talk about the restrictions. But first, the actual way to make the request. We already saw web client in the demo. It's really simple. You set up the download string completed. You do download string. It is limited functionality, though. You don't get access to all of the HTTP features. To get access to all of them, you use the HTTP web request class. We're actually considering, in fact, strongly considering as a future possibility, shipping something that will be usability improvements on top of that whole HTTP client experience, specifically geared at consuming services. So integrating things like the serializer right into the request mechanism, and integrating things like URI templates. It is available as a sample. In fact, I encourage you to go to the site code.msdn.microsoft.com/silverlightws. It has a lot of web service related samples. In fact, I'll show you the site for a second. If you go to releases here, there's a lot of interesting kind of samples here. One of them is this POX proxy, which is what I'm talking about. And to use the POX proxy, it's basically a very similar request mechanism, but it's using generics. And so you can do a get response of a particular XML serializable type instead of actually getting a response and then manually invoking the serializer. And it has a bunch of other usability improvements that you'll see if you download the sample. So those are the three mechanisms. Now let's, all of these mechanisms will only support async, as I mentioned before. And again, the tab experience in Visual Studio makes it easy. You just write your invocation code and you write your response processing code. Another thing to mention is that you can only make requests from the UI thread. So it turns out that there are some restrictions on the types of HTTP requests that you can issue. And to understand these restrictions, I'll show you kind of the entire networking stack. What happens is that there's certainly higher level components like those SOAP proxies, and there's code that you will write, but eventually it all goes down to the Silverlight HTTP request mechanism, which utilizes APIs, plugin APIs that are exposed by the browser, and then the browser in turn handles some aspects of the communications. So it handles cookies, it handles authenticated sessions, caching, and any proxy servers that you're using. And so Silverlight doesn't directly talk to the networking layer. And so the browsers impose some restrictions. Specifically, they don't allow you to override most of the things that they're handling. And then the plugin APIs impose some further restrictions. Not all of the browser functionality is actually exposed through those APIs. And so any rich internet application plugin, be it Silverlight or be it Flash, will have to use those APIs, and it will basically face the exact same restrictions. And so Silverlight will expose all of the HTTP features that's available to it, and the supported features will be basically exactly equivalent to Flash. And if we look at what these features actually are, so in terms of the verbs, to answer an earlier question, we do support get and post. We don't support any of the other ones like put, delete, and any custom verbs. If you're issuing GET requests, you can set custom headers on them, but only on same domain requests. You cannot set custom headers on cross-domain requests. The custom headers that you get back, you can only read the content type header. You don't have read access to any of the other ones. The response codes that come back, you only get notification of success or failure. You can't discover whether it was a 403 or 404 and so on. And in fact, if it was a failure, you don't have access to the message body. And the reason that's important is because this restriction actually prevents SOAP faults from working in the SOAP case. Yes? The question was, with the SOAP client, do you get access to the SOAP headers? Yes and no. Currently, in the beta, you get access to the SOAP headers, but not kind of the IntelliSense metadata-driven access. You can write custom code to get access to headers. We're hoping that in the future we'll actually enable full header support, where if the WSDL specifies a header, you'll get direct access to it. Yep. That's the exact next point. Redirects will work. They actually, for security reasons, in some cross-domain scenarios, some redirects may be blocked. And again, refer to documentation to figure out the details. But basically, in all of the cases that are where redirects are actually secure, they will work. Yep. So again, as I mentioned before, this is not a Silverlight restriction, right? This is a restriction that is in the underlying stack and on top of which Silverlight rides. And so I'll talk more about how to think about these restrictions on the next slide. And so a final set of restrictions comes directly from the browser, and you basically can't override what the browser does. So you can't control caching. You can't turn it off. You get whatever caching behavior is configured by the user in the browser. You can't control the HTTP authentication credentials that you send out. You can't say that you want to send out specifically that username or that password. It will reuse any authentication information that's there cached by the browser for that domain. You can't read cookies. You can't write cookies. You can't control the certificates that you send out in HTTPS. You can't read the server-side certificates that you get back. All of that is just basically a black box that's handled by the browser. Yep.
You said earlier that these restrictions, I mean, those restrictions will all apply to like XML HTTP requests, right? So why impose them on Silverlight?
Sorry, so the way Silverlight works is there's actually a couple of ways that we could have gone with networking in Silverlight. We chose to utilize the browser APIs that are exposed by the browser. We could have gone and actually issue the request directly to the operating system networking layer. That gives you the advantage that we can then issue basically any types of requests. The disadvantage is that you lose all of the features that are provided by the browser for you. For example, you don't need to configure the proxy server to use in Silverlight because it just reuses your browser configuration. You actually cannot do that through the browser. Actually, if Karen can answer that.
Really briefly. The browser actually has two different ways of communicating. One is the XML HTTP request itself, which has site of origin restrictions associated with it. And the second is a set of browser. Sorry, I just messed up. Sorry, my name's Karen. I'm one of the program managers on Silverlight. The browser exposes kind of two ways to communicate. One is the XML HTTP object, and that, of course, has all the site of origin restrictions that you're familiar with when you're inside of JavaScript. And the second is a set of browser plugin networking APIs, which have these restrictions, but also allow us to enable scenarios like cross-domain. So it was kind of a trade-off as opposed to which route we go down. And because we thought that being able to talk to existing services was just really important, we optimized for going through the browser plugin APIs.
So Karen is actually the program manager in charge of the underlying networking stack. So the question is then, what do these restrictions really mean in terms of talking to services? And so the reality is that there are some services out there that because of either cross-domain restrictions or because of these types of restrictions on the kinds of requests you can make, they just won't be accessible from rich internet applications. And that applies to both Flash and Silverlight again. And so if this is to change, and that kind of goes back to the question here, the change must either come from the browser's APIs changing, and we're hoping that in the long term that will actually happen, and those APIs will evolve, both in Explorer and in the Netscape plugin API browsers, Safari and Firefox. We're also hoping that services will basically adapt to these types of restrictions, and we're already seeing that happening. So for example, we have an example of Google Gdata that now allows you to issue a post request with a special header that says to treat it as a delete instead of issuing directly a delete. And so that's a great example of how a service can actually adapt to the realities of what's possible in the browsers. And finally, if you're trying to talk to a service that just isn't consumable because of these restrictions, you can always use a proxy that you self-create that will basically translate something that's not Silverlight compatible into something that is. We're actually toying around with some ideas of maybe providing some either samples of that type of proxy or even tooling to create those types of things. So we talked about the requests. Where can you make them to? What kinds of requests? We'll talk now about how you actually work with the data. So in terms of XML, you do have access to the XML reader and XML writer as kind of the lowest level component. You do have access to link to XML. So you can do your usual link to XML type things, like basically load up your XML into an X element and then do your normal link queries or for eaches. And as you saw in the demo, there's the XML serializer. And in that world, you pre-build a type, and then you call essentially deserialize on it or serialize. It does require manual work to build that type. We're again thinking of providing something that will make this better. We have a prototype of a feature called paste as XML serializable, where you would be able to go to your human readable documentation and copy a chunk of XML, and then through a special gesture in Visual Studio, you'd be able to paste it, and it will paste it as appropriately attributed type. And that feature actually already exists in the xsd.exe tool. It's just a matter of packaging it correctly and more usably. But actually, the way I started doing this, the Flickr demo, is actually by using that xsd.exe functionality. JSON is another interesting format that a lot of services out there use. It's important to understand why JSON is becoming so popular. There's basically two reasons. One is that it's really easy to parse inside JavaScript code in the browser. It's literally one line of code. You just call eval. And secondly, it's really fast. It's actually the fastest format you can parse, again, in JavaScript code in the browser. But of course, when you're doing Silverlight programming, it's not JavaScript code that's running there. And so there's often no real reason to specifically pick JSON for Silverlight. But there are a couple of valid reasons to use it. One is if you already have existing services that are serving up data to Ajax pages, and of course for Ajax pages you do want to use JSON. If you want to then add a Silverlight-based page to that set of pages without changing your server side, you'll probably want to reuse those JSON-based services. The other interesting point is that JSON often results in smaller message sizes. We are thinking of shipping binary XML support sometime in the future to address the message size issue, but it's still not there, and certainly not there for the beta. And so message size is another reason to use JSON. And so it turns out that JSON is important. And just like with XML, we have kind of two ways of accessing JSON. One is, and it's currently just in a sample and prototype stage, and it's at that same place, which is code.microsoft.com/silverlightws. It's basically a link to JSON type thing, where you can, again, load a JSON string into an object and then access it in a weakly typed way. And you can even do fancier link-specific things with it, like you can basically select specific things from a JSON content. So this is kind of the ad hoc JSON consumption. If you're willing to pre-build your type in advance, you can use a serializer we provide. It's called the data contract JSON serializer. You pre-build your type, and then you just call deserialize on your JSON string. So that is that for kind of the fully manual consumption. So you saw the fully automatic consumption with that service reference. You saw the fully manual case where you had to build the URL and build the types and parse them. There is kind of an intermediate ground, which is feeds. And all our RSS and Atom feeds in the world, they basically comply to specific standards. And we're shipping built-in classes to work with these standards, so you don't need to at least do the parsing manually. And this is possible for RSS 2.0, Atom 1.0, and in the future we're thinking of shipping Atom publishing protocol support. And again, because all of these things conform to a specific standard, we have pre-built types to work with these. And really the easiest way to see an example of that is, again, through a sample. And so I'll show you the final demo, which is accessing Live Expo, which is Microsoft's basically classified ads service, accessing it using our built-in RSS support. And so if we look at Live Expo, It basically has this URI structure that has basically in it a keyword that you're looking for. And when you go to that URI, it basically returns to you a regular RSS feed of the classified ads. And again, to consume it from Silverlight, I do a quick check of whether or not it's cross-domain enabled. exploit@live.com/crossdomain.xml exists. It allows access from star, so I can go ahead and use this. As in the previous case, I need to actually build my URL. And when the search button is clicked, again, I use that same mechanism. I still use web client. I still set up the download completed event. And I still issue a request to that URL plus whatever is in my search text box. But when the thing returns, I don't need to do any Xlink or any deserialization. I just create a syndication feed, which is a pre-built type, and I load it from my response. Now this is kind of a bit ugly code here. We're actually looking at options how to make this simpler and just load it directly from a string. But you basically load the syndication feed, and the syndication feed has an items collection. And again, if you go into, sorry, I have this thing running, but the items collection inside of it actually gives you access to all of the standard feed fields, like the publish date, the title, and so on. And I can bind an items control to my collection of items. If I look at the XAML, I have an items control right here with a text block that's bound to the title, that's bound to the publish date, that's bound to the summary. And so that's all it takes. And so I'm actually searching for car classified ads, so I can search for wine. I'm going to truck. For some reason, this is the slowest of the services, but eventually it will come up, and you see the results of displaying a feed. I'm not sure why this is so slow. And here we go. This is a feed bound to the items control with the three different fields actually being bound. Just to quickly summarize, those are the protocols we support: RSS 2.0, Atom 1.0. The support is essentially the same as in .NET 3.5. If you've used our syndication support in 3.5, you'll know how to use it in Silverlight. You can both read feeds and write feeds. It's of course subject to the same exact set of cross-domain restrictions and so on. You actually, the feed OM doesn't do any networking. You still use your web client, and you just use syndication to parse. And again, data binding. You saw kind of the simple data binding in the demo. We are thinking of creating XAML-only data binding story where you wouldn't even have to write that code. You'd basically be able to new up an RSS data source and give a URL directly from the XAML and just bind it directly to UI. So that is that. So what we saw today is creating services for Silverlight, creating them, securing them, and then some guidance on creating public cross-domain enabled services. You saw how to access services that describe themselves using @service reference. You saw how to access services manually by building URIs and parsing data. And you saw how to access feeds. And that is basically it. Unless there are any questions.
Just a couple of questions. One is, what about if you want to persist data to isolated storage? And the second question is, can you clarify what you need in order to bind? What sort of collection or class do you need to bind to?
Right. So, sorry, the isolated storage question?
It's two questions.
Right. So, yeah. What was the isolated storage question?
So, how would you persist data to isolated storage if you wanted to actually persist it on the client?
Right. So that feature is there. It doesn't have much to do with the services features, except that the serializers are used, and so first of all you have stream access to isolated storage, and so you can basically just stream bytes directly in and out. You also can say persist that object in which case one of these serializers that shown will be invoked and will persist in a strongly typed way.
Okay.
And so for data binding, I'm unfortunately not a controls expert. I believe that for basic binding, all it has to do is basically implement INumerable. There's kind of more a two-way binding thing and change notifications, and so we're working on making sure that everything that we generate will actually support all of the right interfaces to actually do the change notification. It might not all be there for the beta.
Okay. Thank you.